702.
The Naked Scientist.
Right. It's been a while. It's been a while since we've been able to do this. Dr. Chris Smith joins us now, the Naked Scientist, to field your science-related questions. Thank you for sending some of them in nice and early, so we could get them in first up there, like in a queue in a way. So, hello, Chris.
I've missed you.
Oh, I've missed you too. That's so good to know.
Yeah, no, I was really pleased. You're back, and I'm back, and here we are. So, Happy New Year, by the way. But no, I really missed you, and it's been like a month or so since we last chatted to each other. So it's really nice to get back together again.
Yeah, it's been more than a month. I was horrified to see that it's close to 2 months. I had the coronavirus, Chris.
Yeah, I heard that you were a bit poorly. Are you all better?
I am much better. I think compared to a lot of some of the other cases and the blogs that I've read, people's stories, I had it more on the mild side. I mean, I had symptoms. Yes, it took about 3 weeks for them to clear. But I had it, I think I would say I was lucky enough to have it on the mild side of things.
Yeah, I've escaped so far. I know this because I've been screening myself because I've got a contact in America who invented a coronavirus test. This one's an antibody test. And obviously you make antibodies if you've been exposed to the coronavirus. So if you measure your antibody levels, you can tell whether or not you've been exposed, because someone who's never been exposed to the new coronavirus won't have any antibodies. So we've been doing this periodically and I've been using my children as guinea pigs as well. So we haven't had COVID in our household yet, and I have my vaccine lined up. I'm booked up to get the first dose. So I think I'm going to be lined up to be shot up with Pfizer's vaccine in about a week and a half's time. So that's because I'm obviously a frontline healthcare worker. And so I think I'll take my microphone along and record the experience of being shot up with the Pfizer vaccine and let you know how it goes. But no, it's a very ambitious program here in the UK. They're going for 15 million people to be vaccinated by mid to late February, which is really quite an undertaking, not just because there's currently a bottleneck in the supplies of vaccines, but also there's a bottleneck in the supplies of people capable of doing the vaccinations. They're talking about running all-night vaccination hubs and things like that with a mass drive-through where you might get vaccinated at 3 a.m, which might have implications because vaccines don't work so well if you give them at the wrong time of day, bizarrely enough. But
Really?
Yeah, that's true. There's quite a strong literature around the role of your circadian or body clock and how well your body responds to various drugs, treatments and other vaccines. And vaccines given at a time of stress, or vaccines given when you haven't slept well, or vaccines given when you should be asleep compared to when you should be awake, don't produce as profound an immune response and therefore as much protection as vaccines given at a more optimal time. So timing is everything here. And so when people are saying we want a through-the-night vaccination regime, I keep saying to people, well, be careful what you ask for, because that might not translate into so many benefits. There may be a higher price to pay for that, not just because people are bleary-eyed and have road accidents driving to get their vaccine in the middle of the night, but because the vaccines might not work as well in people when they are jet-lagged.
Right. So you're talking 15 million in the space of half a month.
It'll be about a month and a half, and that's going to hit the highest priority people first, because we've got an organisation called the JCVI, the Joint Committee on Vaccination and Immunisation, and they were asked to draw up a priority pecking order. Really, people who should receive the vaccine first, and what they did was to look at where the most vulnerable people are. In other words, who is paying the highest mortality price for catching coronavirus, and they put those individuals at the top of the list alongside healthcare workers, people caring for those individuals, and then it trickles down to people like you at the bottom of the list, because people who are judged to be lowest risk, and I would otherwise be at the bottom of that list, but because I'm a healthcare worker, I can be slightly elevated. But it's certainly an ambitious undertaking, and it doesn't mean we're immediately back to normal, because of course 15 million is about a quarter of the population of the country, give or take, of the population we're going to have to vaccinate. We don't do school children because under 18s weren't included in the trials, so they're not in part of the initial rollout. And until everyone is vaccinated and until the levels are right down and under control, we can't take our foot off the brake. And we've got 60,000+ cases per day that we know about in the country at the moment. It's translating into probably 1 million to 1.5 million infections per week running across the country. It's a huge surge in disease activity at the moment, with obviously the country having to go back into lockdown, and we are not alone. The WHO estimate that more than half of countries across Europe are experiencing similarly high watering, high pressure situations like this at the moment, with 25% of them in dire straits.
Yes, and then of course there's a variant, the South African variant. I wish they could just drop the South Africa in front of that.
Oh no, we've got one
every
as
time you
well.
read headlines,
So yeah, you
the
sent
South
us your
African
variant.
is in the UK. No.
Well, you sent us your variant, and we sent you one back. Luckily, it's been contained at the moment in many other geographies, but it's there, and that means it's spreading. So it will, I anticipate, not the South Africa one. We don't know so much about the South African variant yet, but the UK more transmissible variant, which you can spread 70% more efficiently. That's the idea, is that it's changed in such a way that it is capable of passing itself on to other people far more efficiently. That has been seeded to many other places, and so I anticipate that we'll begin to see that add to the mixture and come up in terms of its representation internationally, because Australia have detected cases as well. But people are now concerned about whether both the South African variant and the UK new variant can sidestep the protection conferred by vaccination. So we're obviously a big push to get vaccines into people, but if it then transpires that those vaccines do not provide protection against these new variants, we're going to have to start all over again. So let's hope that doesn't happen. The initial evidence we have is that that's not the case, but we're keeping everything crossed just in case.
Everything, absolutely everything. We've got lots of calls, Chris, and lots of WhatsApps as well. Let's start with Wilhelmina in Pretoria, who has a question about vaccines. Hi, Wilhelmina.
Yeah, and actually, the doctor just answered my one question, but my other question is whether the differences in sequence between the so-called old variant, old virus, and the new variants, are they in the part of the genome that encodes for the S protein or not?
Okay.
Hi, Philomena. The answer is that people are scrutinising these viruses in some detail, and they have mapped out, in the case of the UK variant, they've mapped out where the changes are across the genome, and they're not clustered in just one place. There are 17 changes in that virus, and they're peppered throughout the virus genome, but a number of the changes are clustered in the so-called S gene, which codes for the spike, and the outer coat of the virus is decorated with these sticky spikes that enable the virus to cling on to cells and invade them. And so this does appear to translate into changes in the structure of the spike, at least a bit, which might make the spike more stable, it might make it a bit stickier, but there are other changes elsewhere in the virus that might translate into it being able to grow more efficiently. People are still studying the biology of the virus. They're also still studying the biology of the South African variant that emerged on the Eastern Cape. So we don't actually have the full measure yet of how these changes map onto how the virus behaves differently. But what researchers are doing, there was a paper published from the University of Texas last week. They are taking the changes that have been defined in the viruses, and then they're engineering those same changes individually into viruses that they're testing in the laboratory to see what effect the individual mutations have, so that they can spot what the important ones are, and crucially, what difference that may make to your immunity. They're taking antibodies from the blood of patients who've been vaccinated with, for instance, the Pfizer vaccine, and they're mixing it up with these viruses they're making with these changes in them, so that you can then understand, does this make a difference to the response against the vaccine, and how does that change affect the biology of the virus? The work's ongoing at the moment. For obvious reasons, it's very important to understand how these variants affect the biology and the behaviour of these coronaviruses.
Wonderful. Wilhelmina, thank you so much for your question.
Okay, thanks.
Thank you. Have a great afternoon. Teresa, you're in Boksburg. Hello, Teresa.
Hello there. I'm here under Dr. Smith.
Hi, Teresa.
Teresa here. Last year we had a caller who said he had an operation on his esophagus and something went wrong and he was battling to swallow. In 1999, I had a transthoracic esophageal myotomy. I was referred to a professor in Pretoria in 2016 because my esophagus has now perished to such an extent. And I remember you said to him last year when you spoke to him, if you stand on your head and swallow, your esophagus you will swallow. But with me, I don't have that. If I turn bend forward, the saliva just runs out of my mouth. And if I bend backwards and eat, I choke. Now, the professor in Pretoria said to me, he did various examinations 3 years in a row. And he said to me, apparently I am the only one. He had a conference call with other gastroenterologist overseas. And apparently I'm the only person who's had this operation. It's strangely weird. I cannot now swallow rice, pasta, macaroni and cheese. My list of what I can eat is becoming less and less and less. So I thought you might be interested in this.
Okay.
Well, thanks for sharing your story. It's certainly true that...
just a moment, Teresa.
Sorry.
Yes,
it's
just a
certainly
moment
true
so that Chris can respond.
that under normal circumstances, that your esophagus can produce what we call peristaltic waves. What this means is that it contracts in one place, and then the bit next door contracts, and the bit next door contracts, and the bit next door contracts, and behind it they're all relaxing. And so it causes a pulse of movement down the esophagus. And so if you can imagine the esophagus is a tube and it's got something in it, and then there's a bit behind where there's some food pinches off, and then that bit pinches off the bit next door and pinches off the bit next door, it propels the food or whatever's in the esophagus forwards in front of it, down into the stomach. If something interrupts that process, and this could be, there are various diseases, one's called achalasia, that can affect the behaviour of the esophagus, then this can stop happening. And obviously, if you have surgery, if you have to have a bit of the esophagus replaced or taken out, sometimes that can also have consequences like that. And other diseases can also affect the process. So it may well be, I don't know the background to your particular issue, but it may well be that the condition that you had that necessitated the surgery or the intervention in the first place has continued, or it wasn't completely repaired in the first place, and as a result you've got back to a point where you don't have that peristaltic wave properly working to propel things down your esophagus and things are getting stuck. But thanks for telling us about the story anyway, and I hope that you are able to at least get enough calories in so that you don't lose weight, because that's the critical thing. It's staying well nourished, because if you eat well and remain healthy, you keep the rest of your body healthy.
Right. Teresa, thank you for sharing your story. Next, we go to Dennis, who's in Foy's. Dennis, you have a question about Einstein?
Thank you. Yes, what I need to understand, how did the scientific scholars come to accept Einstein's equations of special relativity and general relativity in the absence of physical observation? We now know that as we go along, those equations are being confirmed, but they were accepted before confirmation, which sounds to me a bit unscientific. I will listen on the radio.
Thank you, Dennis.
Hi, Dennis. Well, the bottom line is that Einstein was a profoundly good mathematician, and so he could show mathematically what should happen. And so people said, well, this would explain an enormous amount, and the maths all lines up, and you can independently test the mathematics in various ways, suggesting it did look credible. But then when they actually did the experiments, hey presto, the bugger was right. And they did various experiments. For instance, the most classic one is people taking very accurate clocks, putting one on an aircraft, keeping the other one on the ground. You synchronize them at the start of the experiment. You fly one of them at very high speed on an aircraft. You bring it back together and you see the clocks now tell different times, because when one clock is moving at a high speed, it affects the rate at which time ticks for that clock, and that proved the concept of special relativity. Then there was also the most amazing experiment conducted when the transit of Venus was measured from two different places on Earth, and that eclipse enabled them to actually test Einstein's theory of gravitational lensing, the idea that massive things in space, by massive I mean things with a lot of mass, like a star, will bend the fabric of space, and if you bend the fabric of space, you bend light that's coming through space. And the experiment was that if you measure where things appear to be, and then you measure where they actually are, if this effect is real, then and space is being bent by a massive object like our sun, then actually you should see these objects appearing to move in the night sky. And that's exactly what Arthur Eddington's experiment was able to prove. And so they took the theory and then did the experiments to corroborate it, and Einstein is still being proved right to this day, because people are now doing experiments, most famously the Nobel Prize-winning experiments into the discovery of gravitational waves, which also proves moreover some of the points that Einstein's predictions, some of the things that he predicted. Just amazing to think, 100 years ago, this guy is doing maths and making these ideas, having these insights, and 100 years later we're finally testing them really, really thoroughly and proving he was absolutely right.
Was it unscientific for it to be accepted without this kind of proof?
I don't think so, because we accept lots of things on the basis of the theory and independent tests of the theory. So you can test things mathematically, but then when you can actually take a theory and make observations and show that the observations fit your predictions, that again further corroborates our understanding of how we think things are working. There's always uncertainties, there's always unknowns. Science isn't about answers, it's about asking questions and narrowing the gap between those questions. And that's what Einstein effectively did, but there are still many unknowns.
Thank you, Dennis. Great question. John, you're in Parkview. Go ahead and ask Chris your question.
Yes, hello, Dr. Chris.
Hi.
I'm a chronic cramp sufferer. It keeps me awake at night, 2, 3, 4, sometimes 5 times a night. I have to wake up and run around to relieve the cramp. Now, my question is really twofold. One, despite all the salt I take, despite eating healthily, I'm still suffering this way. But one of the main questions I think I'd like to put to you is what is the brain and the nervous system telling the body to do that creates the cramp?
Where's the cramp happening?
I beg your pardon?
John, where do you have the cramp? Is it in your leg?
Mainly in my legs and feet.
Okay, there we go. Thank you. Chris?
Oh, sorry to hear that. Sounds agony, especially when it begins to disturb your sleep, because sleep deprivation and sleep disturbance leads to stress, and stress leads to even more sleep disturbance and even more risk of cramps and things. The answer with a cramp is that normally when we move a part of the body, you are doing that by moving a muscle. When you move a muscle, you have a message that comes down a motor neuron from the spinal cord into the body of the muscle, where it fires off a signal, a chemical signal, that then causes an electrical discharge in a particular group of muscle fibers. And that squad of muscle fibers is called a motor unit, and they begin to contract. As they contract, signals are sent back into the spinal cord from special receptors both within the muscle itself and also in the tendon of the muscle that say how hard the muscle is working. And also signals from the opposite muscle that works in the opposite direction are being sent into the spinal cord. All this information is compared so that the muscle contracts at the right rate to the right length and by the right amount without overdoing it. But for some reason that we don't thoroughly understand, when you get a cramping situation, this system breaks down, and instead of there being a feedback loop that controls how short the muscle can contract and how long it stays contracted for, the muscle just goes into overdrive, and whole motor unit groups, so big squads of muscle fibers, just contract uncontrollably and stay contracted until something causes them to release. Usually that's fatigue of the muscle or the process that's injecting the chemical to say contract stops or whatever. It does appear to happen more as we get older. There are some people who are more prone to this. There can be different chemical imbalances. Drugs can do this. There are some diseases that will make this more common. So it will depend on what the cause is in you. The unfortunate news is that some of these things are correctable. And if you've got particular chemical balances, electrolytes can cause this. If they're put right, the problem will go away. But it doesn't sound like that's the case in you. Have you been properly investigated would be my question. Worth getting it investigated. There are some drugs that can help. Some people prescribe quinine, the same stuff we give for malaria. It can make night cramps a bit better, but it's not a magic bullet. But other than that, it's a difficult nut to crack, I'm afraid. And I would urge you, though, if it's becoming worse and it's a new thing and it's got worse and it's really seriously disturbing your sleep, then I would go and make sure it's been properly investigated, because there could be a reversible cause. But your doctor needs to see you to know that.
Yeah. John, that's their advice this afternoon. Thank you for your question.
Good. Thank you, Dr. Chris.
Thank you. That's John in Parkview. So, Chris, when is your big day for the jab?
A week on Saturday. It's my birthday coming up this weekend. I was hoping I might get it on my birthday, but I'm not getting it on my birthday. I'm getting it as a late birthday present. But it'll be a week on Saturday down to the hospital I work at. They've got a big centre there rigged up, and they've got a very high throughput. They're doing hundreds of people per day going through to try to vaccinate all of the frontline staff. The idea being, of course, that at the moment we have got so many thousands of people off work across our health service, not many of them actually with COVID, but many of them with contact with COVID. And that contact means that the theoretical risk they may catch it and they may come back to the hospital and give it to other patients and members of staff means they have to isolate. So they're all off work. And this means it's becoming harder and harder to run the service. So the decision has been made to really prioritise getting healthcare workers protected so that we can maintain our quality of service.
Absolutely. Well, can't wait for you to tell us all about it. We have
I'll do
one
my best.
Monday. Yeah, we've got one more Monday before we get the account. So we're going to
For
go
J Day,
vicariously through
Jab
you
Day.
When that happens. Thank you so much, Chris. Till
It's
next
a
week.
pleasure. See you soon, Azza. Bye-bye.